Hi, welcome to howtostats.com. In this video I'm going to talk about reporting the results for a MANOVA. For those who don't know, I uploaded a series of videos on how to perform a MANOVA in SPSS, and I did it in two different ways. One was through the GLM procedure, which allowed you to do the MANOVA, and then if you got a significant MANOVA, you followed it up with ANOVAs, and then subsequently a bunch of post hoc tests. So that was videos 1, 2, 3, and 4 for the MANOVA on the How to Stats channel. And this is how you would write up the results for that type, what I call type 1. I might have a better name for that, maybe GLM type 1 or something like that. But I've written up the results for this type of analysis with the references in the tables, and I guess the key points are, in my opinion, you should always report the correlations, in the opinion of other people too. So the first thing you would do is report the correlations and the means and the standard deviations amongst your dependent variables. And you can do it like this, and this is a little trick when you've got names for all your variables, which you almost always do. If you add numbers to them in the first column, well, then you can just use numbers in the row, and you can save a lot of space that way. So someone can see, oh, 8 is actually spatial 2, so it's quite easy to navigate this type of table, and it's actually much smaller than it would otherwise be. And here are the means and standard deviations in the same table on the right side, so that's clearly demarcated. You're looking at something different here. So it's a real cool way of presenting results, in my opinion, for a manuscript or a report. So after I talk about the correlations, I go through box's M value, and that's to test the hypothesis that the covariances are the same amongst all groups. That is, the covariances amongst the dependent variables. But I've got a reference here in the results section from Huberty and Potowski saying that the box's M value you wouldn't evaluate at an alpha of 0.05, but instead at 0.005. So it's tougher to reject the null hypothesis. And in this case, we don't actually want to reject the null hypothesis. We want the assumption of homogeneity of covariance matrices to be true. So I've got a little section on that with a useful reference. Then I go into the MANOVA and I report the results, and I reference, you make use of Pillai's trace, which is the most robust to violations of the covariance matrix assumption. But my sample size was so huge I felt confident of using it. I suspect in other cases people will be tempted to use Wilks lambda, which is totally fine. You probably see that just as often as you do Pillai's trace. Because this is not the interesting, sophisticated way of doing a MANOVA, it's just doing a MANOVA to help protect against the chance of making a type 1 error. And in the video I say, if you've convinced yourself and others that that's the way to do it, then here's how you'd report it. So here I've got the ANOVAs, but before I do that, I actually report Levine's F-test, because I have to test the assumption of homogeneity of variance for the 9 ANOVAs that are now going to be performed on all these 9 dependent variables across the 3 levels of education. And I find that none of them, I think I found 2 of them rejected the null hypothesis of homogeneity of variance. But then I cite Howell 2009, who, based on his summary of the research, says that if you don't have one standard deviation or variance 4 times larger than the smallest, then you should feel confident of doing the ANOVA, and that the p-value associated with the ANOVA will be relatively accurate. All right, so that's a key statement here, that the assumption of homogeneity assumption was violated, but the standard deviations were still not 4 times greater. So I got Howell 2009 for that. And then finally, you're doing a series of post hoc analyses, and I chose Fisher's LSD because if you've convinced yourself that the MANOVA protects you against making type 1 errors, if it's statistically significant, then why not go for the most powerful statistic? Some people might say, well, you should use Tukey's, or maybe some kind of hybrid Bonferroni correction, or something like that. And I haven't done it that way. This is just a guideline as to how you might go about getting your results written up. And I'll put some links to some other papers that have written up some MANOVAs. Actually, probably only for the second case. I'll see if I can find one for the first case where they think it's because they protect against the type 1 error rate. So I end up doing all the post hoc Fisher LSD